Hi everyone, we're going to use the principle of mathematical induction to prove that 1 plus 3 squared plus plus 3 to the n minus 1 equals 1/2 3 to the n minus 1. And before we get started, just remember this is really like 3 to the 0 plus 3 to the 1 plus 3 squared. Alright, so we're going to check first for condition 1. And that means we're showing that it's true for n equals 1. So I'm going to take these two terms, and this is your summation of this whole sequence. This is geometric sequence. So you have 3 to the 1 minus 1. Everywhere there's n, I want you to put a 1. So 3 to the 0 equals 1. And this equals 1. So that should be the first term. This is the sum with this is your first term here. Now we've got to do condition 2. Condition 2 is you assume it works for n equals k. So that would be 1 plus 3 squared plus plus 3 to the k minus 1 equals 1/2 3 to the little k minus the big 1. Then we show, so this is your assumption, you show it's true for the next term, which is n equals k plus 1. So it's going to be 1 plus 3 squared plus plus 3 to the k minus 1, and your next term is going to be 3 to the little k. And that's because if you take your previous term and add it's k plus 1 minus 1, you get 3 to the k. After that, it would be 3 to the k plus 1, then 3 to the k plus 2, and so forth. All right. Now, we have, also you have to add the next term to your summation. So if you added a term here, you have to add it here. So this is going to be 1/2 3 to the k plus 1 minus 1. All right. Now, the next step is we already know what this equals. So this equals 1/2 3 to the k minus 1. Right here. That's based off our assumption line. And then you're going to add your plus 3k, and it has to equal this. So basically we have 1/2 3 to the k minus 1 plus 3 to the k has to equal 1/2 3 to the k plus 1 minus 1, like that. All right, so we want our right-hand side to look like this side. So now we are left with simplifying this. So what I notice is on my final answer, I need 1/2 3 to the k plus 1 minus 1. That's that. So let's simplify this. This summation has a 1/2. This term doesn't. So I'm going to write this out as 3 to the k power minus 1. This 1/2 can be written like that. Plus 3 to the k. We need the same denominator. So if I put a 2 under here, I have to multiply this by 2. So what this ends up being, all over 2, 3 to the k minus 1 plus 2 times 3 to the little k. Now if you look at this, we have one of these plus 2 more of those. So that's 3 times 3 to the k minus 1 divided by 2. Now, using your product property of exponents, this equals 3 to the k plus 1 minus 1 divided by 2, which is the same as 1/2 3 to the k plus 1 minus 1. So since conditions 1 and 2 are satisfied, the statement is true. And that's it. Thank you. Have a nice day. Bye-bye.